dataset sourced from Kaggle include social media metrics like, share, comment, keyword, and platform interaction across TikTok, Instagram, Twitter, and Facebook. It helps analyze what drives content to go viral and how users engage with it. Social media plays a major role in shaping opinion and behavior, but viral trends can be both positive and harmful. This project uses descriptive statistics, correlation, regression, and decision trees to explore engagement patterns. Thingsboard is used to visualize trends in real time while Google Colab handles data processing. Together, they provide a clear and ethical framework to monitor and understand social media trends effectively. Problem statement. In recent years, viral trends on social media platforms such as TikTok, Instagram, and Twitter have significantly influenced public behavior, especially among youth. While some trends promote creativity and awareness, others pose serious health, safety, and social risks. Dangerous challenge. Misinformation campaign and addictive scrolling behavior contribute to increased mental health issues, public safety concern, and decreased productivity. Despite the rapid spread of this trend, there is limited real-time monitoring or analytics to detect and respond to potentially harmful content before it escalates. Most current systems rely on manual reporting, which is reactive rather than preventive. This project addresses the lack of proactive monitoring by proposing an IoT-based system that collects, analyzes, and visualizes real-time viral trend data. The goal is to identify trends that may be linked to harmful behavior and provide timely insight to parents, educators, and policymakers. Objective. First, to identify and analyze viral social media trends by collecting real-time or recent data from public platforms or dataset like hashtag, keyword, user engagement. Second, to design and implement an IoT system that monitor at least 3 input parameters such as trend, popularity, keyword type, dangerous, harmless, and geographic location. Third, to visualize the data through Thingsboard dashboard to present trend in a user-friendly format like line chart, bar graph, and alarm.
First specification we will monitor is views. Views tell us how many times a post has been seen. By analyzing this, we can identify how far the content is reaching, when user activity is at its highest, and how audience attention changes over time. It gives us a good overview of content visibility and general interest. Next, we look at likes. This measures how many users reacted positively to a post. Tracking likes help us recognize which content is popular or well received. It also gives us insight into how user preference shift over time. We also monitor shares. This shows how many times people send or share a post with others. If a post is shared a lot, it means it has a good chance to go viral. By looking at shares, we can understand what kind of content people like to pass on and how far it can spread through their networks. Lastly, we also monitor comments. Comments show how often people reply or talk about a post. They help us see which posts get people talking and sharing their opinions. This also helps us tell the difference between people just looking at a post and those who are really interested and getting involved.
Step first, import the library. Numpy for numerical operation. Tanda for read and manipulate data. Map for the graph. Volume, create snaps. Request, connect to web service. And Google Colab for access Google Drive. Step 2. Mount Google Drive. Connect your Google Drive to your Google Colab. After that, we must copy the path and paste at the dataset path. Step 3. Read the dataset. Dataset path is the string that holds the location of your CSV file. PD read CSV. Read the CSV file into a data frame named SF. A data frame is like a table, row, and column. Step 4. Define things for access. For access token is used to identify and authorize your device on Thingsboard. Then the URL is where we will send data by informating it with the token, the server known which device the data belong to. SF each row goes through the data frame one row at a time. Create a dictionary data with view, like, shares, and comments. In row, convert the value to integer just to be sure. Request post send this data as JSON to the Thingsboard server. Response status could show if it worked. 200 usually means success. 500 means something went wrong.
Based on our Thingsboard dashboard, as you can see, we are using 6 different types of widget. There are 5 different types of chart widget and 1 alarm widget we are using for analyzing our data. We're using line chart, bar chart, scatter chart, stat chart, and time series chart. Before we run the simulation on this part to get our result, we have to run each of this line coding to collect. So after I run all of this and I start running the last coding, it will display the number of 200, which is the data successfully realized and transferred to the Thingsboard area. So I'm going to open this dashboard. As you can see, the graph chart is successfully generated. First chart is about line chart. This line chart shows how lights and comments change over time. The green line which shows light went up and down a lot. The purple line which shows comments stay mostly the same. This means lights change more often while comments stays steady. Next is the bar chart. The bar chart shows how many comments and shares each post received. Most posts had comments and shares. One post had a lot more comments than the others, and another had the most shares. This means people were more likely to comment than share. Next is the scatter chart. The scatter chart shows the relationship between views and comments. Each but is a post. Posts with more comments also had more views. This shows that more comments usually means more people saw the post. Next is the stick chart. The stick chart compares shares and likes over time. The baseline shows shares and appear more often and taller than the green lines, which show likes. This means users share posts more than they like them. Next is the time series chart. The time series chart shows how views and shares change over time. The tail line for views goes up by the yellow dots for shares stay. This means people view posts a lot but they share them as much. The widget was added to detect unusual activity. It shows a critical event when comments go over 400,000, a warning when shares go over 30,000, and alert when likes go over 30,000. This means the alarm is working and shows alerts correctly when the set limits are passed. In conclusion, Google Collect was used to process and analyze the social media data, including tasks like statistical analysis, regression, and decision tree modeling. We provided a flexible and efficient environment to handle the dataset and run various analysis methods. Thingsboard was used to display the results through real-time visualization. It helped show trends in views, like, share, and comments in a dynamic and interactive way. This made it easier to understand how engagement changed over time. Together, Google Collect and Thingsboard offer a powerful setup for analyzing and visualizing social media trends. This combination made the findings easier to explore and understand, supporting better decisions based on data.